It's awesome. Welcome to day 2 of DevOps Days Minneapolis 2019. So, I hope you learned and shared a lot yesterday and are energized and ready for today. And if you need anything, talk to anyone with a staff badge, and the info desk is open through lunch today. And like yesterday, we have live captioning. So if you feel like you could benefit from this or from power, please come find a seat near the front. And we have space for wheelchairs up front and standing tables with power all the way to the back. A little housekeeping there. Make some noise if you visited the sponsor hall yesterday. Yeah. Remember, sponsors keep our ticket price low, and they have a lot to offer you, like solutions, jobs, free stuff they definitely don't want to take back with them. So make sure you get entered in all their raffles, and then come back here to this stage at 3 p.m. to win your fabulous prizes. I saw some amazing Legos and other things in there, so you're going to definitely want that. And for your colleagues who didn't make it to this event, and now you're dropping photos in Slack and they're full of FOMO, these are the remaining North American DevOps Days for 2019. You don't need to take a picture of that if you don't want to, because it is all on devopsdays.org. But if you're thinking to yourself, this was so fun, I want an excuse to go to more of these, devopsdays.org/speaking has open CFPs. Most of them are international for the rest of what's posted right now, but watch in early 2020 and more US events will be posting. So we had some fantastic Twitter traffic yesterday. By the way, even though we have it like literally right up on the board, people have been still being creative and making their own hashtags, which is fine. But clarity, if you say hashtag DevOps Days MSP, people who are looking at hashtag DevOps Days, say that 3 times fast, might miss it. So our official hashtag is hashtag DevOps Days. You can join the MSP Slack team. We have a monthly meetup. We don't have our next meetup posted yet, but once we recover from this, we will pick some time. Okay, and be sure to check out the job board out in the foyer. I was really happy to see it's full of jobs, and you can take a picture for a friend if your colleagues are watching. Okay, on codes of conduct, I want to mention this again. I think most people were really happy with yesterday, and I want to keep that good feeling going. So remember, we have a code of conduct. Just like every place ever where humans interact, we want to make sure everyone has a good time. We are all different, and the TLDR is treat everyone with respect, because everybody has something to share and something to learn. Okay, so what's happening today? What are we going to learn? We have 4 great speakers before lunch, more on them in a little bit. After lunch, we have more choices. On this stage, we'll start selecting open space discussion topics, and our workshop across the hall in the Duluth room is going to start right away after lunch. If you went to open space opening yesterday, you kind of know, do you want to go to open space right away, or do you want to go to a workshop? And we have that chaos engineering workshop right after lunch tomorrow, and you'll need your laptop for that. And then during the afternoon break, we'll have the raffle right here at 3 p.m., and then we'll have more open spaces and another workshop about blameless postmortems. On that topic, by the way, I want to quick do a blameless postmortem of my actions on this stage yesterday, because I was impatient and I was kind of blameful and I was kind of, where are my slides? And I was not picking up the thing that would have let me put my slides where I wanted them. And instead I was not understanding, and I was kind of making it look like the AV crew was doing something wrong, when actually I just hadn't picked up my clicker. So if you have in your organizations those kind of misunderstandings that can arise, just keep in mind, it happens to all of us. And going through especially at 3 a.m. or on a stage in front of hundreds of people, we can do things that are wrong. And in order to fix those, we should have good postmortems. So that workshop might be highly relevant to your interests. And also, while we're here, can we have some quick round of applause and shout out for our audiovisual crew? Because look at this. There are lots of people, including people you don't see, who make all this possible. So, all right. And again, don't forget to come to the raffle. Don't forget to go to open space and workshop. The 10 of you who are still here at 5 p.m. can watch us take an organizer picture right on the stage when we close things out. But we're not having any formal closing ceremonies or anything. So make sure you make it to the the break and raffle to catch up with everyone before they're gone. And I am sticking the landing right on time. We are going to now hear from Debbie. Thanks.
Thank you, Bridget. It's me again, which means it's sponsor time. Yay! We love our sponsors. This is a great time. Without further ado, I have Tim here from Ahead.
Thank you. DevOps Days, Day 2. You guys ready to bring it home? All right. So thanks for having me. My name is Tim. I lead the DevOps Solutions Group at Ahead. We are a company of about 400 strong. We're headquartered in Chicago, but we have about 50 of those 400 here in Minneapolis with an office in Edina. We've been growing pretty steadily, so please stop by the booth. We'd love to talk about how our plans for growth and your own personal growth may align. We got started in 2007, so we're about a 13 or so year old company, and really our roots came out of the data center space. So one of the core pieces of our messaging and how we help customers is really centered around going from the legacy kind of enterprise where we have stakeholders and customers and shareholders and goals to meet and bosses to please, but also kind of take the innovation from the startup culture and bring that into the fold as well. So bringing these two aspects of DevOps and excitement together in a way that keeps the wheels on the bus, so to speak. So we got started in cloud in about 2012, and a lot of our journey at that point was helping customers automate and go to cloud and accelerate that journey. Most people now are in the cloud, which is great. So now it's a lot more around migrations and how we can kind of take certain initiatives in your business and try to make them move faster without compromising on security and things like that. Our DevOps practice started a couple of years after that, and it was really, going to the cloud for the sake of cloud didn't make a lot of sense. So it was how can we take our applications and the projects we're doing there, whether it be on premises or in the cloud, and really leverage these tool sets and these new services in a way that makes sense. So DevOps for us means facilitating tool chain discussions, helping to not force tools down people's throats, and provide kind of an open dialogue for generating the best possible tool set. And also creating kind of a layer for experimentation in there so that we can continue to evolve. And really taking that message and scaling it throughout the business. So it's not just one team of 6 or one team of 10, and then another team kind of over here does something different. It's how can we scale it across the enterprise and really start to bring some benefits to our business and grow. And I mentioned the stitching, which is a really important piece for us, both culturally and in terms of the tooling, but bringing, like I said, kind of security and, operations in as well. So we call these our 5 imperatives. These are the 5 things that we sort of look at being, part of the legacy of where we come from, but also part of where we want to go. So automation, relentless automation makes us sound a little bit overzealous, but the thought that if we're not automating, ask the question, should we even be doing this thing? And if we should be doing this thing, why shouldn't we automate it? Intelligent operations being all around, that we have legacy tools. Every cloud vendor wants us to use monitoring tools there. It's how can we pick the right set of tools that give us, what we need without too much overlap. And then how can we bring that into a process that makes sense for our business? New technologies, cloud native, containers, serverless, they start to bring up all these questions of how do these fit in things like a CMDB and change management? How do these fit, from a help desk operations standpoint when I'm trying to troubleshoot something? Intelligent operations is all around making that job and that message easier across the business. Integrated security, of course, we want to shift security left. It's been a message in DevOps. I think this is our 3rd DevOps Days Minneapolis, and it's been, growing year over year in terms of being part of that message. So working with our security practice to really understand, again, the legacy and how we bring that into the modern as we're doing more tool chains and even just more discussions and bringing security into those discussions. And of course, enterprise cloud, right? So it's once we're in the cloud, it's not let's just create servers and spend more money on those servers. It's let's use some of the cool new database technologies or IoT technologies and use them in a way that, again, makes sense to the business, helps us grow, helps us meet our customer hopes and dreams. And so, these are our 5 digital imperatives. We help customers by transforming and adopting some of these or all of these. And if this sounds interesting, which I hope it does, please stop by our booth. We'd love to talk more about this with you guys. And again, thanks for DevOps Days Minneapolis for having us. Thank you to you guys for being here. And let's bring it home on day 2. This should be a great day. So thank you.
All right, thank you, Tim from Ahead. Be sure to stop over at the sponsor hall, put your name in the raffles. That's coming. That'll be happening at 3 o'clock today.
Thank you so much, Debbie. Okay, so here we go. Day 2, one of the things that I really wanted to do is hear more from technologists in our local area about what are the problems that we've run into and solved in our organizations. And you know what? They're not all social technical. Some of them are, but some of them are just every single kind of funny / hilarious / terrifying thing ever. So if you can please welcome John Engelman to the stage. John, come on up.
Thanks, Bridget.
Thank you.
Awesome. Great to see everyone this morning. I'm very excited to be up here talking to you about what was probably like the worst 2 months of my life. That's actually not entirely true because it's absolutely terrifying. When Bridget and I started talking about doing this talk a few months ago, I was thinking like, oh yeah, this is gonna be great. This is exactly the type of talk that I want to hear. I think people get a kick out of this. And then as I started reviewing my Slack and pulling together screenshots of everything that went on, I started having anxiety attacks, reliving this moment, thinking, oh my God, I'm not gonna be able to do this. I'm gonna be bearing my soul to everyone here, and they're gonna be like, this guy's an idiot. And then I came yesterday and I was listening to all of our wonderful speakers yesterday, and I went home and I looked at my wife and I said, it's official, I'm a complete imposter. Because everything yesterday was amazing. Like, it was so great. So I sat on that all last night just thinking, like, do I call Bridget? Do I say I'm coming? I'm not coming. I'm sick. My kid's sick. I'll use her. Like, what are my options here? And when I woke up this morning, it dawned on me that this is actually quite perfect because all of the talkers yesterday, all of our speakers were talking about the complexity of the systems that we build out there, and how do we do blameless retros and all these wonderful things that make us better at doing our jobs. And that's what I get to share with you. I get to share an actual practical case of this and what we learned from it. So a couple disclaimers before I start. First, this is not a talk about any specific technologies. I will be mentioning technologies, but it's not about them. It's not about what they do well or do poorly. I'm not advocating for them or against them. I'm not saying that you should use it or you shouldn't use it. Everyone picks the tools that they pick for their reasons, and that's great. But we do need to be able to talk about the actual specifics here, right? So I will be talking about those things. What this talk is, like I said, is just an analysis of a complex system and how it failed in ways that even to this day I don't fully understand, right? Mysteries of the universe type stuff, right? And I hope it's really just a learning opportunity for all of us. So quick little background before we get started so that you can understand the context in which this failure happened. For the last couple of years at Target, we've been building an internal application platform that we call TAP. We have a few principles on it, mainly that as an enterprise organization, we have a lot of legacy infrastructure that exists for reasons. And we can't just rip it all out and replace it with the shiny good and best of the day, right? We have to make it work. And the biggest thing that TAP's trying to solve is giving our developers across the entire organization the ability to effectively use that infrastructure to do their day-to-day jobs, right? So that's what TAP's trying to do, is provide this unified experience for all of these things. So when we built TAP, we made a few opinions up front. There's two environments. There's prod and there's not prod. There's no stage, there's no UAT, et cetera, et cetera. There's just the two. You can create things inside of that, but that's all. We don't use virtualized networks. So every workload on tap runs on our core network. So we don't have that layer of complexity from that side. We issue IP addressing through DHCP to those things. We have to deal with multiple data centers, multiple cloud providers, multiple endpoints, WAN, LAN, all sorts of stuff. And then we have multiple compute providers. So we run hundreds of Kubernetes clusters behind tap. We run OpenStack installations. We run schedulers that talk to libvirt behind tap. And our developers are completely transparent to any of that stuff, right? So that's the system that we're trying to build. From a workload perspective, then, because we want that the ability to move that workload around, that workload has to be self-contained. So every workload that we deploy out contains all of the capabilities that it needs to operate to do things like logs, metrics, talk to the platform to get config and secrets, et cetera. We run things like HashiCorp's console, HashiCorp's vault to provide some of these things because, well, I mean, who doesn't run HashiCorp, right? Like, these technologies are awesome. I've been using console since the 0.2 days, which was about, like, I don't know, a month after they released the project. And they're just very, very good at what they do. But we picked the tools, we picked each of the technologies in tap to do one thing well, right? We don't want the Swiss Army knife that's going to do all the things, right? Like, pick the thing or build the thing to do one specific task, right? Very microservice-y in that sense, right? And it lets us pick the tools that fit our patterns the best and also have are the most resilient. So that's the context. That's where we're starting from. So what happened? Day 0 of many. So our whole problem started with a software-defined networking update, so an SDN update in one of our networking fabrics. So I mentioned earlier that we don't use virtualized networks. That's still true. But we still have to have things for broadcasting route information into the switch infrastructure. And that was what was getting updated. So this shouldn't be too big of a deal, right? But we're using console, right? And a console cluster works by every node inside of the cluster gossips information to other workloads. Specifically, it uses a toolkit, a library called SURF, which is based on SWIM, which stands for Scalable Weakly Consistent Infection Style Process Group Membership. And this is the only time that any of us should be deciding to put something with infection in the name into our prod systems. The way that SURF works is that intermittently, periodically, workloads ping each other, saying, hey, are you there, right? And if that workload comes back, then we think you're healthy, and we can tell the rest of the cluster that, hey, that node's healthy, right? In this way, we can the cluster works around network partitions or other things that can happen inside of a complex network. However, when things go wrong, and that workload, when one workload tries to ping another and it doesn't get an answer or a response, it doesn't immediately say, hey, that thing's gone, mark it unhealthy. Because we don't actually know who the unhealthy is in that case, right? So what SURF does is that workload then asks another neighbor. It asks his friend or two friends to also, hey, can you go check that workload as well, right? So then those workloads ping in, and then they can tell you if it's up or not, right? So we can figure out where's the partition, what's the part of the network that's actually offline, and all that type of stuff. What happened to us, though, and what started this whole thing, is that our SDN update didn't hard down the network. It didn't just fail. That would have been awesome. Had that happened, I wouldn't be standing here today for you. Instead, what it did is it made the network flap in and out. And when you're dealing with this kind of gossip system that's sending these probes around the network on periodics, and you're intermittently getting responses and not getting responses, you're basically getting a whole lot of messages in the cluster saying, that thing's here, that thing's not here, that thing's here, that thing's not here, right? And it goes on and on and on and on, and you eventually end up in this state that we got to. So our problem was that the cluster was flapping like tens of thousands of nodes in and out. And it was broadcasting all these messages about these nodes flapping out, so all the healthy nodes then had to process all the messages about these nodes flapping in and out, and that caused problems. It was at this point that we started looking through various console changelog messages, because we had been running a version, it had been running great, and why update when we don't need to update? Well, we missed the update then that was like, hey, if you're running a cluster of more than 10,000 nodes, you probably should be on this version. And we had blown way past that at this point. So first step was to maybe update some of those things, right? Kind of, retrospectively, we probably should have kept up to date more on those things. Okay, so where did this go from being like a minor annoyance to an oh crap moment, is because we have these isolated workloads, every workload in TAP is running a console agent. And because now we had this tsunami of messages coming into each one of these things talking about how the cluster was flapping in and out, the CPU and memory requirements of this console agent started getting higher and higher because it needed to do more work. This is a problem when you're running something like Kubernetes behind the scenes, because you have to allocate shared resources off your compute platform to these workloads. So as the console agents started asking, trying to do more things and using more CPU requirements, all the workloads on a Kubernetes worker started doing the same thing. Well, CPU and memory are finite, so when that happened, the Kubernetes worker then said, I can't do anymore, I'm unhealthy, mainly because we were sucking so much CPU out of the Docker daemon that kubelet couldn't talk to Dockerd anymore, so it couldn't tell us the state of the node. So the node marked unhealthy, and in its brilliance, right, in order to keep our things up, Kubernetes says, oh, if that node is unhealthy, let's move all the workloads off of it. And so it takes all those workloads that are needing much more resources than they typically do and move them to other nodes that were running a bunch of workloads that were using a bunch more resources than they normally needed. So that was great, right? Because that just caused more problems, because as these workloads terminated on one node, they had to say, hey, cluster, I'm leaving. And when they showed up on another node, they had to say, hey, cluster, I'm here. So we just started generating more load inside of cluster, and the more load, or inside of console, and the more load meant more problems, and we are off to the races now with a full-blown, cascading failure, thundering herd, all the things. So what could we possibly do at this point? Well, first was we need to remove that affected network fabric, right? We need to get things out of there so that we can let the messages die down, and we need to get all the workloads inside of there move to healthy areas of our platform. So we got the team together. We did all that. The end. No? Right, okay. Yeah, you didn't follow. Obviously not, right? So day 0 to week 1. So moving the workloads off, that was actually something that we were able to tactically do within a couple hours of the problem starting. And we were able to kind of patch it up and keep it in a, what I want to call a stable, degraded state at that point. We knew things were bad, but we were able to keep them up mostly for developers to continue using, and it wasn't impacting any type of production systems at that time. Luckily, this problem all happened in our non-prod environment and not our prod one too. But we kept working on this and kept going at it. And one of the biggest things that we didn't have at the time is because of our confidence in some of the tools that we use. We had combined 15, 20 years of experience running console in production systems between engineers on our team, we failed to realize what insights and what telemetry we properly needed off that cluster to understand what was going on in this kind of thing. We knew we had the basics, right? We were watching the things that everyone watches, but at this point we were digging down and looking at console source code and looking at all the various hidden metrics that they don't talk about anywhere and plotting them on dashboards to see if we could figure out what is causing this degraded state as we go. This is never a graph that you ever want to see anywhere in an operational dashboard, right? Exponentially increasing with oscillations. Not going to be a good day. Not going to be a good week. So bad sign, right? So at this point, this is probably about the time where I had my first real good cry at about 2 a.m. Sitting at my kitchen table because I had just literally no idea how this could be happening for things. It turns out that there's another kind of intricate behavior inside of the console agent that if you don't go through something like this, you might not learn about. And that's that obviously when it's processing messages, you have to have a message queue inside of it, right? So new messages from the cluster come in, the agent processes those messages off, and then also rebroadcasts those messages out to the cluster, right? So because it's gossiping, right? So if I hear that a node left, I got to go tell the rest of the cluster that the node left, and eventually the cluster converges to some state of here's who's healthy, here's who's in and who's not in. The thing is like most messaging queues, you can only hold so many messages inside of that queue. So when you're generating a whole bunch of them, you hit this limit. And the obvious thing to do from a development point of view is that when you hit the max, you just stop accepting messages into the queue. This is the exact wrong thing you want to have happen when you're having a thundering herd problem, because new messages are more important than old messages. More specifically, like join messages are even more important than leave messages. If you told me that you're here, then I don't need to process or rebroadcast that you weren't here. This is not what console was doing for us at this time, right? So as we were churning these workloads and pushing them through, we were rebroadcasting these effectively invalid states. And so even though we had moved workloads out of our affected network fabric, we never could get the cluster to forget that those workloads weren't there anymore. Because the messages about them leaving and joining, that giant problem, was continuously replicating throughout the cluster. It was being rebroadcast by nodes because of this problem, right? Because the agents couldn't churn through them. The message loads were just too big. So we had basically what we started, we referred to as surf poisoning. We had a state that we literally could not eliminate from console without a hard shutdown and delete of the cluster state, which wasn't really an option for us until like week 2 or 3. Which funny enough is that when we did do that, it actually didn't fix the problem, because we ended up right back in our as soon as we turned things back on, we would delete the state, turn it back on, and it would look great. And I'd go to bed, and 8 hours later I'd wake up and I'd be looking at this again, because there was some node out there that still had the old state. You couldn't just delete the console servers and delete the server state. You actually had to delete the state on all of the nodes in the cluster, and it's not realistic to shut down 20,000 instances and delete their state and come back online. That was not a thing. So what were we doing, or what were the impacts that people were seeing at this point? We were starting to see availability problems in our non-production environment. Our load balancer system for our platform is hyper-converged to console, right? So you don't have to define load balancing in DNS or certificates or anything. We just look at we have an opinionated pattern on how you deploy, and we give you load balancing. So our load balancers talk to console. So we had problems where the load balancers had routes for workloads that didn't exist anymore, or they had backends for IP addresses that weren't assigned to that workload anymore. So we were starting to now see impact after some time. We started seeing slow start times for applications as they would boot up because they need to check into console to say, like, hey, I need my runtime configuration, right? And I'm going to wait for you to give it to me. And console was becoming so burdened with the load that it couldn't effectively respond to those things. And when it did respond to it, sometimes it just gave us the wrong answer because someone would make an update to a config, and the console servers need to replicate that new config to the other console servers, and it couldn't do it in an effective amount of time. So the client workloads might have gotten a stale read, so they'd get incorrect configuration when they came up. This was further exacerbated because our developers were taking it upon themselves to fix the problem with their apps by redeploying them. So we just keep churning more things, and it's great. I love that they have the initiative to go fix things like this. But the bigger problem that we had is because of this kind of state where, we don't know what the current state of the cluster is, and we haven't really converged, is that as they started redeploying these things, their workload that had this IP address in their not prod environment, when they redeployed it, would release that IP address. And then someone else deploys something in prod, and suddenly something in prod has that IP address from DHCP, and now our not prod cluster is trying to talk to our prod cluster to ping that node for, hey, are you there? And luckily, thankfully, by some magical means, these clusters didn't converge their states together, because we did have at least that configuration in console, right? But they were sending the messages. So the agents were picking them up, and they were processing those, having to process those messages and say, hey, I'm not part of your cluster. Why are you even talking to me? So that was great. So now not only do we have like this weird state in one environment, but we also have that environment then poking its fingers at the other environment, and starting to cause some problems over there. So there's disaster on the horizon at this point, right? Because as soon as we start affecting prod, then we're really in we're in a storm at that point. So what do we want to do at this point? Well, it's like 3 weeks in, maybe 4 weeks at this point. I don't know. It all kind of blurs together. And we're thinking, you know what? Console's our problem. Let's just get rid of console, and all our problems are going to go away. Yeah, I'm not sure if that's going to be successful or not. But what we did know is we needed, one is because of our opinionated form of the platform, we didn't need the capabilities that Surf was giving us. We didn't need the gossip, right? We needed console service data. We needed instance health data in order to drive the load balancers. And we needed workloads to be able to get like a KV. But most of our developers weren't doing any of the more advanced console things. And we definitely weren't like sending event messages through Surf throughout the cluster and things like that. So we had an option here. So late one night, well, half the team was in India visiting our people out there, we decided, you know what, we're just going to get rid of this, right? So we actually wrote a replacement for the console agent that provided the same API, but didn't have any Surf in it. So we just wanted to eliminate this broadcast storm that was occurring. So, we buckled in, and over a few hours, days, weeks, whatever it was, we wrote this new thing and started deploying it out to an environment, and slowly started bringing that down. It also helped because we could understand the message flow better, right? We didn't write console. We can read console code, but we didn't write it, and we can only know so much about it at that point. So something that we wrote in-house, we could have a little bit better grasp of how it was working at this scale. So, month 2, when we get into this. So we got our up agent out there, what we call up agent. We got it out there. We got Surf out of the environment. Things were, again, back into this stable, degraded state. But we would still, from time to time, see things like this in our console metrics, where everything was working fine, and then suddenly we get a little worse, and a little worse, and a little worse, and a little worse, and then we're like, oh crap, devs are going to start complaining, and we'd have to do everything, which our first thing was, we'll just reboot it at the end of this. So we were in that mode for a little bit of time of just every morning, we're going to reboot the console cluster, and everything will be fine for a day until we can so we can get some sleep, and then maybe we'll figure this out tomorrow. So we then started doing even more things. We put some proxies in front of our console so that we could black hole some of the requests and reduce the load, and all sorts of things. And we finally got ourselves to a really happy place. And then month 3 or so, we we started having this problem again. This little graph started reappearing one day. So I was like, this is really weird. This hasn't been happening for days. What do we do? So we were trying to compare our not prod cluster to our prod cluster. And we were digging through metrics. And there was a metric that we had in our metric system that we had from our not prod cluster, but we didn't have it in our prod one. Like, that's really weird. So we're like, this looks interesting, we want to compare it. So we looked at the console configs, and there was a discrepancy between the telemetry settings between the two clusters. So, of course, we updated the working cluster to match the not working cluster, and redeployed. And thankfully, this started happening immediately. In about 10 minutes after deploying that change, our prod cluster started exhibiting this problem. And I say thankfully because if this was any longer, if this was an hour or 2 hours down the road, there's no way we would have associated the change in the telemetry settings in console to this problem happening. We would have immediately assumed, at this point in time, we thought that it was client workloads doing things against console that was causing our problem. We were super confident in that, and we were super wrong. So we just happened upon this answer. So we rolled that change back, and then went to our not prod cluster and rolled the change back, and everything got happy. And I started hating myself because I was like, that was like 3 months that was caused by a change that I had introduced on about days 0 and 10 minutes in this problem. So there's a lot of learnings here on this. So end of the story is that we finally got it back to a place where it's healthy. And how did we address this, like as a team, right? So when we initially started having this problem, we went into immediate firefighting mode, right? It was fix, what's the symptom, fix the problem, right? Like whatever it needs to be do, get it working, right? We don't want to impact our customers. And once we got past that, we were trying to understand, both why did it happen, and why is it still kind of continuing to happen, even though we've fixed the underlying problem that we thought caused it. And retrospectively, the worst thing here is that we didn't have the insight that we needed, because we weren't ever looking for this problem in a distributed system. We'd never seen it before. And so we didn't have a baseline for what was normal. We didn't know, we weren't looking at how many requests all of our clients inside of our environment were doing to console, because it had never been a problem for us before. So once we got into this state and we're like, well, maybe it's client workloads doing this, we're like, well, there's 10,000 TPS, requests per second happening. Is that normal? Is that not normal? Did that change? We had no idea, right? We had no baseline. So we couldn't have a comparison. The only thing that we could compare against was our production environment. But we couldn't see trend, right? We couldn't see what had happened over time leading up to this change. How did we tackle it in the weeks, right? We started looking at what is the complexity in the system and where can we reduce some of that complexity so that we can have a better handle on things, right? Really complex software, when you run it at scale, it's not linear, right? When you start running at scale, you're talking about orders of magnitude more complex, right? And you're talking about interactions that will happen at 10,000, 50,000, 100,000, million, instance type stuff that you're never going to see in your lab environment running 10 servers, right? And you probably won't be able to foresee it. So I really hope everyone's listening real closely. If you ever want to try and do this, reference this as hey, maybe surf isn't the best thing, or let's at least have measurements for some of this stuff. The other thing that you need to do when you're building a distributed system at scale is that you need to have levers that you can pull, right? You need to be able to turn things off. You need to be able to isolate, and you need to be able to isolate at scale, right? You need to be able to do that in a way that you know that you're going to put yourself in a degraded state potentially, but at least it's a known degraded state. So you can start eliminating problems along the way. And then in the months, what were we really doing? Well, it was kind of split. We were split between just trying to maintain that stable, degraded state for our developers because we had caused a lot of impact for them and we wanted to start getting some of that trust back. But then we also needed to start making these small, precise changes in the system and then observe their impact over time. There's the idea of like Lean and Six Sigma and things like that. And one of the examples they always talk about is like when you turn the dial and you watch how it changes, and then you're like, oh, that's not right. So I turn the dial back the other way, and it moves some more, and you just keep turning the dial, right? And eventually you get behavior that you don't know, right? So make your change, make it small and precise, and then watch it, right? Like let it burn in and see where it stabilizes out at, and don't try to keep responding to that. And then finally, you just have to clumsily happen upon the answer to all your problems randomly one day. And fix the world. So lessons, don't be satisfied with what you have, right? Like the technologies that we have out there, they are fantastic. They're really good at their job. Their industry has tons of experience with doing these things, and it's great to run them, right? Because we contribute back. But if they, for some reason, don't work for you, don't shy away from reinventing that or tweaking them or doing things. When you're running at scale, think about these new failure modes that might occur, right? Like get outside input in and think about, what is really the worst case, right? Even if you've never seen it before, it doesn't mean it can't happen. Build in your kill switches, build in your levers, make sure that you can control the system or direct its flow in a way that you want. If you're building a complex system, you can simplify it by making some opinions up front, right? And you can build that system to make those opinions mutatable or flexible so that you can change them over time. But having the opinion will at least give you some type of structure to work from. And then finally, have your insights, right? Put the metrics. Look at everything that you can, right? If you can track everything, if you can record everything, that's great. If you can't, that's good too, right? But you need to know how your system runs at scale, and you need to be able to see it over time, trend over time. With that, again, I was very happy to be in front of you. I hope that this was interesting for you all. My name's John Engelman. I'm going to be hanging out at the Target table. If you want to talk about TAP or this problem or any of the other exciting things that we're doing at Target, I'd love to hear from you. Please stop by. Thank you for your attention. Oh, I forgot.
Ooh, what'd we forget?
I forgot. Everyone say hi.
Oh, yeah. Oh, wait, let me get back in the picture.
Oh, this is so slow, and I'm just ruining things. Hi.
Hi.
Perfect, thank you.
Love it. The speaker selfie is classic. Okay. Hi. I actually have a mic that you need, so that's why I'm back on stage. And then we're going to hear from Scott and lots of wonderful folks.
Welcome to the stage from SPS Commerce, Olivia, Sanjesh, and Nate.
Hi, I'm Nate Anderson from SPS Commerce. I'd like to compliment you all on the nice stylish necklaces you've been wearing this week. SPS has been involved in the DevOps business for a really long time, as you can see from my stylish t-shirt here. At the core, we are a SaaS business focused on facilitating the back end of retail. Our customers need to talk to each other a lot, and so we facilitate that communication, transformation of their data, analytics, et cetera, on the way through, amounting to over 500 million documents a year these days. So as we go through, we've been fairly successful at this so far. Our business has been growing as almost 20% year over year. And as we go through, this also means our traffic grows, sometimes exponentially, depending on the different system we're talking about. So our engineers have had to embrace the DevOps Agile culture to go through and make sure that we can handle the features as they go from all the way through from start to finish. To get there, we've used a lot of different technologies. You're going to recognize a lot of logos up on the screen. We've used all of these and more as we go through, using the best tool for the job. We've also had to keep our architectures up to date. We've been in the microservice business for ages. Thousands of containers, millions of Lambda executions a day. We're also, more recently, have embraced event-driven architectures, processing almost 1 billion events a week so far and growing that as we go. So as we go through this, we've learned a lot from this adventure we've been going through. And to embrace one of SPS's core cultures, giving back, here's Sanjesh Kumar to talk about that.
Thank you, Ned. An organization's culture is a reflection of both what you are as well as what you are aiming for. We are here because DevOps provides us a platform to evaluate and improve our culture. Here are a few words to describe SPS culture: winning, innovation, learning by working together, diversity and inclusion, and community investment. One of the core values of SPS is giving back. SPS gives back through community by sponsoring numerous events throughout the year, such as DevOps Days, Mini Bar, Hack the Gap, Annual Student Hackathon, and many Women in Tech programs. For example, the Aspirations in Computing. The Aspiration in Computing is a program where high school female students are supported as well as given a summer internship. To talk more about summer internship and how it helped her career, I'll pass to Olivia.
Hi there. My name is Olivia Alberts, and I am one of the Aspirations interns this summer. I'm on the team that builds retailers on our network at SPS. At SPS, we use Jira to assist in our task management. Now, what that means is that every sprint, my managers will need to spend about 3 to 4 hours going through every routine task and making subtasks out of them. That's a huge time spent. So my job this summer was to automate this process. So I'm going to take you a little bit through that program right now. So let's see. Right here, you can see just a test ticket. As you see, there are no points on this ticket or subtasks assigned yet. So let's hop over to the UI that I made to centralize this program. We're going to fill in a couple queries, like the Jira query in Jira query language. Next, we're going to select if we would like to point and or subtask this ticket. And then once we click Run, we're brought over to a results screen that tells the user everything that the program did. So let's hop back over to that ticket, and we will see that points were made, as well as subtasks. So that's my project. I'm really excited and proud of the real, tangible business impact that it's going to have on SPS and our team. And we have a team full of people who are super excited and passionate about the stuff they do. And lucky for you, we're always looking to grow our team. So please swing by our booth, talk to us about any of the projects that we're all super passionate about. Thank you.
Thank you, SPS. Now we have Adam from GitLab.
Hello. First, I want to thank all the volunteers. This is my second time here. This is an outstanding DevOps Days event. I've been to many around the country. So if you guys could just thank all the volunteers that helped put this together. Yeah. Probably I want to thank them because they're brave enough to give a sales guy a mic and say I only have a minute. So I'll be quick. GitLab is a single application for the software development lifecycle. So that includes, project management, CI/CD, code repo, and application security. I want to make sure everyone knows in this room, we're more than just a code repo. We're about making your life easier so you can innovate versus integrating a bunch of tools. Please stop by the booth to learn more. We are an open core company. We're 100% remote, and we are hiring in all departments. So come on by, learn more. If you need to check out, if you can't come by the booth, go to getlab.com. Thank you. Have a great day.
Thank you, Adam. And now we have Roz from D2IQ.
Hi, Roz Lombardi with D2IQ. Many of you know us as Mesosphere. And Monday, as you see on the slide here, on Monday we changed the name to D2IQ. And the rationale behind that is it really describes what we do, from technology to services to advisory efforts, et cetera. We work with many organizations to bring their cloud native initiatives to enterprise scale. You might be familiar with some names, Netflix, Airbnb, Twitter, all using our platform. But we made a transition. How many people here are using Kubernetes? Raise a hand. All right, pretty good number. How many here have put Kubernetes into production? A few less hands. So stop by our booth, because we really like to. We've built a new Kubernetes distribution called Convoy, all open source, open APIs, with support. And we can show you how to bring up Kubernetes at enterprise scale in 30 minutes. Thank you.
Thank you, Roz. Now we have Peg from Merrill Corp. Thank you.
Yeah. Hi, everybody.
Peg and Company, I apologize.
We have a great crew here from Merrill, and I want to tell you a little bit about Merrill. At Merrill, we have products that clients love, tech that's interesting and modern, team members and people that are outstanding, and we have a culture that we're really, really proud of. So I want you to remember us by this little song. Maybe you've heard it before. Row, row, row your boat gently down the stream. Merrily, 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 merrily. Come and join our team. So please stop by our booth. A shout out to Joel, our recruiter, who's at our booth. Come by and say hi, and we're super happy to be here. 4th year sponsoring, and thanks to all the organizers. That's what we got.
Thank you very much. And next up, we have Drew from VictorOps.
Now you know the stage is good.
Thank you. This is my 4th time at the DevOps Days Minneapolis, so it's great to be back. I think this is our 5th year sponsoring for VictorOps. And so for those of you that aren't aware, VictorOps is an incident response system. And so you can hook up your monitoring stack and connect with ITSM tools and chat tools to get the right subject matter experts in front of a production issue when it does occur. For those of you that aren't aware, we were acquired by Splunk last year. So I know a lot of folks do use Splunk. And so come by, come see what we're doing. A lot of interesting things. Splunk is investing heavily in us, and we like to show you guys what we're building and what we're going towards. So thanks, everyone. Appreciate your time.
Thank you very much. And now back to Bridget.
Thank you so much, Scott. Okay, so we've heard about the kind of stuff that makes, I don't know about you, but I was sitting there listening to John's story and having like flashbacks to being on call and just kind of the cold sweats. And it's like, oh, so I'm very happy it had a good ending, but wow. So that was amazing. So when we're thinking about this kind of stuff, obviously as technologists, we start thinking about what are we gonna build so that we have better systems that we can hopefully fix and predict and maybe even auto-remediate, whatever. And so this is why I'm really excited to have our next talk. I would like to welcome Martez Reed to the stage. If you can join us, Martez. We have a lot of systems we can build that can do a lot of interesting things, and Martez is going to talk to us about it. Let's see, we have a remote there. Okay, wonderful. So without further ado, please welcome Martez.
Thank you, Bridget. As Bridget mentioned, I'm Martez Reed. This talk is going to be on intelligent pipelines, which is intelligent deployment pipelines, which is a perfect segue from John's talk. A little bit about myself. I am a principal field solutions developer at Puppet. Really what that means is I work on the education enablement team. I help with training both externally as well as internally at Puppet. Roughly 10 years of IT experience, and my focus probably the last 7 or 8 years or so has been on automation. So a couple of ways to find me: LinkedIn, Twitter, GitHub. Do a bunch of different things that are hopefully very interesting to other people, and there's a bunch of different ways to find me. So let's kind of dive right into it. Let's start with kind of preferencing what CI/CD is. It's one of the common words that people hear. Oftentimes people don't really know what the full intricacies of it are, but for a very high-level overview, typically the CI part is the continuous integration, which deals with the automated testing as well as potentially automated builds of code. Continuous delivery and continuous deployment. This is one of the things that sort of I tripped over when I first started getting into the whole CI/CD thing. Like, what's the difference between CD of delivery as well as deployment? For me, kind of the simple way to think of it was that delivery was basically making sure that the package was ready to actually ship, or in this case, whether it's code or whatever, to be able to ship to production, and there's actually a manual gate before it gets to production, as opposed to deployment, which is that essentially the code is going automatically through to your production environment. So now that we've gone over that, so this is a common diagram of a CI/CD pipeline that you'll often see. And for me, one of the big things is, kind of the reason for this talk is that we often see this, and there's a box dedicated to deploy to production, and right before deploy to production, there's some application acceptance test. But for me, I kind of want to focus on the area here that there actually rarely ever is a box for, that I see, is how do I make that decision to deploy to production? I think for most people, it's oftentimes a gut feeling of, yeah, now it's about the right time. The application's been tested, everything is good to go. And then for some people, it's just random guess on what to do. And so for me, kind of to highlight that was, I think for most people, deploying into production is really just a black box in terms of at least our mental model as it relates to, if we're not deploying to production, let's say multiple times a day, there's a situation where we start to lose context of what is or isn't in production. This kind of alludes to John's talk of the reference of, there's oftentimes so much infrastructure as well as different dependencies within a production environment that it's very difficult for any one person to keep track of every particular nuance of the environment. So I'd like to think that essentially we're, for the most part, deploying into a black box. The thing I would liken this to is the Frogger scenario, for those that have played the Frogger game. Imagine playing Frogger, but having blinders on to where you can't really see to the left and can't see to the right. You know a truck is coming, but you just can't see the truck. So you kind of jump out there and like you get hit by a truck, or maybe sometimes you're lucky and you don't get hit by a truck. It's really just kind of a crapshoot. So that's what kind of this black box scenario is for most. And so how do we take those blinders down? For me, it's starting to look at, kind of as John mentioned, things like telemetry within our environments. What is the current state of the environment? We've got some things that are already in the IT ecosystem that help with some of these things. And so things like Jira for ticketing, actually interrogating potentially AWS for some information. Things like Splunk, your data log, to get information about what the environment is that we're actually deploying into that maybe we haven't actually deployed into in maybe a month or so, or maybe even longer. So an example with AWS might be, is a certain availability zone in AWS actually up? I mean, it might be a scenario where there may be either nothing in there currently, or maybe there's something there and maybe it's not actually degraded or not actually being utilized because maybe it's a redundancy component. So before we actually deploy to production, maybe we can check that to actually validate that it is actually up and running. In addition to that, I mean, there's a lot of different things that we can validate within the environment in terms of AWS, things like the EC2 status, S3, IAM, which maybe is, especially with like IAM or KMS, things that may not be used on a daily basis for some environments, to where I go to push to production and now there's an issue with the actual deployment because one of the services is unavailable. And so it's not an outage, but it does take up time and also cause churn in terms of what actually needs to be done. And oftentimes, as I've realized, some of the errors with the tools that we use may not throw this specific correlation that says, hey, there's an issue with KMS or KMS is in a degraded state. Typically, we'll get the actual symptom of, hey, I'm trying to deploy an EC2 instance, but I can't actually encrypt the volume. And the actual root cause of that may be an issue with KMS. So starting to look at things to help us collapse that time of troubleshooting, as well as to help us gain better context when we're trying to troubleshoot. In addition to that, this is an issue I've ran into multiple times when deploying is in larger organizations, there are multiple teams that manage different aspects. In this case, let's say an AWS environment. And when trying to deploy a certain application or an EC2 instance or whatever it may be, it's dependent upon another team's security group being available within the environment. And so I go to actually push the code, and there's a failure because the security group isn't there within the environment. While it's not a major issue or an outage, it does require time for me to actually walk through that process to address the issue. So things like the required security groups, required KMS keys. So oftentimes these issues are more things that we see from the symptom side of, I try to run an operation and the operation fails, and most applications I've seen don't throw very good errors to really get you right to the root cause, or maybe somebody's written an article or a blog post that maybe gets you there, but that's still a couple of hours as part of that process to try and remediate whatever the issue is. For me, this is a really big one, because this steps out of the purely technical and starts to step into the interdependencies of different teams. So in this case, maybe there's a network team that manages, let's say, an AWS VPC configuration, VPNs, firewalls, things like that, and potentially looking at a source of truth like Jira. Hopefully, if it's being updated and maintained properly in terms of ticketing, then we can start to leverage that information about the environment to potentially help us to make a better decision in terms of when we make a deployment to production, to be able to identify maybe there was maintenance last night that the network team did on maybe some critical firewalls. For me, I think that would be really helpful to be able to have that information when I make a decision to deploy to production, because maybe that's the issue. Maybe the network team upgraded a Palo Alto network firewall within AWS to a newer version, and now I'm experiencing issues in my production deployment, but now I don't have that direct correlation to understand that, hey, they updated something on the Palo Alto firewall, maybe there's a bug there, maybe there's an issue there that's causing an issue with traffic coming into my application, but without actually knowing that the network team made that firewall change, I may not have the proper context to actually properly troubleshoot that. And so I spend maybe hours, maybe days, maybe weeks, maybe months, potentially trying to track down the issue of what happened. And so things like that of ongoing maintenance checks, of identifying other teams that are doing maintenance within the environment to understand that correlation possibly between when I last pushed to production to when I now push to production, to understand the potential ramifications of what my push is going to have to deal with in the environment. In addition to that, I mean, being able to look at our telemetry to be able to ingest additional data around, is it maybe there's something going on right now where maybe customers are flocking to the website more for, let's say, maybe a potential offer or a deal, or maybe it's just one of those occurrences like everybody wants to buy something from our website now. Is maybe this the right time to push to production while we've got maybe 2x or 3x the number of customers that we would normally have? So in addition to that, we can also start to look at potential other dependencies within our environment in terms of what their performance is, to identify scenarios where, kind of as John mentioned, maybe a console agent is causing issues in the environment for these particular applications. It's not something that's very specific to my application, but it is going to affect the application of maybe there's additional database load in the environment. And maybe it's a scenario where my application, I've made a new feature change to where it now puts additional load on an already taxed database. And so now I'm chasing my tail because there are performance issues, and I'm trying to figure out why there are performance issues. Oh, most people are going to say, well, you just pushed new code to the production environment, so it must be the application code that you pushed. But maybe it was a combination of an existing issue as well as the code change. And then another thing is looking at our logging and information, starting to actually make real use of that for additional information and additional insights. So starting to look at comparing potentially what we've got in our existing pre-production environment to our production environment to get insights from there. And also starting to identify potential transient errors that aren't really being tracked but are actually creating issues. So for me, this is great information and great insight to help remove that black box of what production is and start to make it a clearer picture. And so for me, it's also starting to potentially look at the diff between what our lower level or let's say pre-prod environment looks like from our production environment to get real insights that we can leverage to make actual decisions around how we deploy to production. And so kind of on the logging example, one of the things is oftentimes I've been in environments where there's a bunch of errors and if you're a more junior person or somebody new to the team, you might go and say, well, hey, there's all these errors in the logs. And the other person says, well, yeah, that's fine. That's how it always is. That's usually how most environments are, is especially with Java. I've looked through Java stack traces and it's isn't somebody going to fix this? Oh, no, that's perfectly fine. That's how the application is supposed to work. And so when we deal in these real life scenarios, how do we address that issue of I can't go fix every single error, but all I'm going to get is noise. So how do we start to actually make use of that of, let's say before I push to production, I've got a pre-prod environment that mimics the production environment, and all I'm really doing is I want to identify the difference between the two. I'm expecting error 101 and error 609, but if I see error 933 in the pre-production environment, and I do a diff between that and the production environment, I can start to see, hey, there's an actual issue as opposed to the noise as usual that we see in most environments. And the other thing for me is also as we start to step more and more towards sort of everything being codified, we get into scenarios where we can start to do this of, let me take my CloudFormation or my Terraform and actually do a diff between the two to start to see if there are issues that are going to potentially present themselves because of differences between the last time I pushed to production and the next time I push to production to identify, get a good sense of what's actually changed within the environment. And so this is really, for me, critical in scenarios where there are multiple teams working on multiple components within the Terraform code to be able to leverage, okay, the network team owns the networking piece, they've done it all in Terraform. The security team owns the security piece, they've done it all in Terraform. Can I potentially do a diff between the code that they manage and the code that I manage from the last time I pushed to production and the next time I push to production to be able to at least see what has changed within the two environments between the time of the last push and the next push. The kind of extending upon that model is starting to look at essentially everything being as code to start to store artifacts of essentially the whole map of what production looks like at the time I deploy to production and be able to compare it to the next time I push to production. So the code, let's say there's Golang app, it's already being codified. It's stored in GitHub or GitLab or whatever it might be. I've got that. I can do diffs on that to see all of the code changes from the last version push to production to the new version push to production. If you're using configuration management, you can also store that. The Terraform, the Packer that maybe the application is running on for the AMI or the template or whatever it might be. And I could potentially store that in like a CMDB, like a ServiceNow, and be able to version that as version 1.1 of my application when it was pushed to production. This was the state of all of the components that go into building out the infrastructure. And then be able to do a diff quickly between the two if the need arises to say what changed between now and then to be able to say, hey, maybe it's a console config or something like that, to be able to identify issues that like that we can actually be able to track down very quickly because we're actually being able to look at data and metadata about the environment. So along the lines with data, there's a session going to be on this, but chaos engineering. So the thought with chaos engineering is more thoughtful than this, but for the layman for me is break stuff and see what the impact is. So this is the actual more technical description of what chaos engineering is. Essentially, you're running experiments to see what the state is of the environment. And so for me, this goes along the lines of getting additional data into the environment to be able to make rational decisions and thoughtful decisions about what we want to do in terms of deployments. So kind of walking through the example, this is a scenario where there's an AWS load balancer and there's 2 EC2 instances. Traffic's going to the first AWS EC2 instance and life is good. But there's an outage for some reason. Somebody killed off the instance, it broke, whatever it might be. And so now, for most that have worked with load balancers and AWS, what's the thought of what's going to happen? The thought is, it's going to fail, traffic's going to fail over to the other EC2 instance. But what happens in a scenario where it doesn't actually fail over for various reasons? Whether it's an invalid health check, manual fixed health check, somebody actually did something maybe they shouldn't have done and went into production and made a change manually on the console, and now you push some new Terraform and it breaks that health check, so now you've got bad health checks. But when you push the code, you didn't realize that there was a bad health check because everything was going to the healthy EC2 instance, or even just the failover time. So the goal of this is to start to ingest additional data in terms of, especially in like a pre-production environment, about what the potential impact is going to be when you push to production. In addition to that, start to look at issues with the EC2 instance. So there are a number of things that can impact what's going to happen in terms of the availability. And so the goal is to start to identify some of those things before we push to production. And this is a number of tool examples related to chaos engineering. One is Netflix's Simian Army, Chaos Toolkit, which is an open source tool, as well as Gremlin, which I think they're actually going to be doing a session later today. But the goal is to be able to break stuff, to try and figure out where the issues are within the environment, to be able to ingest that data. And so, kind of along those lines, there's a lot of data, a lot of telemetry, a lot of information being ingested and we're being bombarded with. For me, kind of the goal is to start to think less about the mental model of information that I can keep in my head as it relates to what does the environment look like, and start to really lean towards and take advantage of some of the tools and platforms that we are now starting to see actually really become more prevalent, such as machine learning. I did reference machine learning. I will not mention blockchain or some of the other buzzwords. I did actually think this was relevant. But essentially, the thought around machine learning is to have the machine start to do some of the work for you. And especially when we start talking about taking these vast amounts of data in, how can we actually make actual sense of this data? So real simply, 2 standard types of machine learning, supervised and unsupervised. Supervised basically being you giving the machine learning the answers beforehand. Unsupervised being it kind of figures out that data. I'm sure there's more people that are well-versed on machine learning that can provide better explanation of that, but that's, as a non-machine learning person, that's how I grasp it. So kind of as I've talked through this, how do we take all of these different data points and start to ingest them to actually form insights to help me actually make an informed decision when I push to production, as opposed to, yeah, just push the button, it's good, there's no issue, and then everything breaks. And so for me, one of the things around starting to be able to leverage those insights is ingesting all of that data from our continuous integration process, as well as our continuous delivery process, and even production, and sort of feeding that into a central point to where we can start to, as human beings, start to look at this information in a more sensible manner and have that be our decision as it relates to when do and don't I push to production, and actually be able to have essentially almost like a dashboard that says, this is what things look like. Yes, it's probably a good time to push to production. No, it's not a good time to push to production. And over time, that'll start to be refined and start to be able to potentially used as input into potentially automated machine learning around making a decision to where it's not a human gate anymore. Then we can start to leverage a scenario where it's the machine making the decision based upon the decisions that the humans have made prior to. And maybe it's not even a fully automated manner. Maybe it's certain scenarios where I've provided guardrails around quote unquote the machine to make a decision. Maybe if it's make sure there are no open issues in Jira that are critical for networking or security, or maybe make sure there are no metrics that are above this certain threshold. And then if it meets that certain criteria, then maybe it's time to make the decision of, yes, make the push to production. And so this isn't an all or nothing scenario where like, hey, let's just turn it over to the machines and let's just have them sort of figure out when and when not to push to production. There are guardrails and things that we can do to put in place to provide safety, but also take advantage of the machine being able to ingest data about the environment at a much faster rate than we're able to. And so when we start to think in this sort of methodology where I'm ingesting data, not for me to look at it, but I'm ingesting the data for the machine to process it and for me to be able to actually gain the insight from the information that the machine is processing, then it's a scenario where I don't mind turning on extra telemetry or extra logging because I'm not actually ever going to be looking at it myself, only if there's an issue, but I'm allowing the machines to actually start to process that and actually take advantage of the advances in technology outside of just going full-blown, we're going to do everything, everything's going to be AI, and the machines are going to think for us. I think that'll come at some point, but I don't think that's where we're going to be at for the next probably 20 to 30 years. So while we're in this place of where machines don't do everything for us, I think it should really behoove us to take advantage of the insights that we have available to us. I'd like to thank you for your time. I am Martez Reed. Hopefully this talk was helpful.
Thank you so much, Martez. I feel like just from all of the things that we're hearing that are helping us figure out how to improve these things inside our own organizations, it's wonderful. It's very exciting. All right, we have a short break here. If you want to go visit the sponsors, you have about 20 minutes. We're going to be back here at 10:45. But if you want to go visit the sponsors now, get a snack, have some coffee, and enter all the drawings because you know you just have a little bit of time left to win.
It's me again, which means it's sponsor time. Come on in, find a seat. Quick, quick, quick. How's everyone doing? Great time? Woo! All right. So give people a couple more seconds to get their seats. And without further ado, I have Dynatrace here to give another pitch. Thank you.
Is this on? All right. Hey everyone, my name is Jeff No. I'm a sales engineer with Dynatrace. My favorite band is Trip Shakespeare. Anyone? Anyone? Whoever that was gets a t-shirt. And I'm from Cloquet, Minnesota. So I am a lumberjack, and I'm okay. All right. Let's talk about the realities of today's environment, and I want to talk about how Dynatrace can help you create an unbreakable continuous delivery pipeline. So first, the complexities of today's world, we're no longer talking about a simple lift and shift to the cloud, right? Our applications are going to be a combination of our on-premise data centers plus one or more cloud environments. And in terms of monitoring, what that means is you need a solution that can view all of these environments and bring it together into one map view of your application. Dynatrace can do that. In terms of scale, your applications need to be able to scale, and what that means in terms of monitoring, your monitoring solution needs to scale along with that. Dynatrace can dynamically instrument your applications as they grow and map them for you. Containers and microservices are the de facto standard for application deployment, and Dynatrace can fit right into this environment by installing a single agent per host and instrumenting these containers as they spin up. We do not need to be built into your containers in advance. The DevOps lifecycle means we're delivering faster than ever before, and we're bringing business development and operations together, and they all need answers about what the status of things are, what's going on. Dynatrace can be a solution that helps provide answers to all of these stakeholders. And finally, end user experience. Users expect our applications to behave as simple as Google or Uber. Dynatrace can give you visibility into your end user experience, and we now even go as far as offering the ability for you to record videos of your users interacting with your applications that you can then use to debug their sessions or understand how they're using your user interface. All right, so it used to be that excellent DevOps pipelines were reserved for companies like Amazon or Facebook, but really today anybody can build a great pipeline. Unfortunately though, what we've seen in our surveys with a lot of our customers is that, if you look on top here, the median customers aren't really doing that great. There's a lot of room for improvement. But in the 95th percentile, we do see some excellent work being done, and the real question I have for you is, where are you and where do you want to be? Dynatrace can be a solution that helps you get to where you want to be. And if we take a look at what Dynatrace has done in the last 8-9 years, we've made significant improvements with our own DevOps pipeline. And what we're doing is building those solutions into our product, integrating with tools like Jenkins and AWS pipeline and the Azure pipeline to be able to let our customers achieve these same results. So here's an example, just a couple stats from a workshop we had with a large bank in the United States recently, and what they've been able to achieve through automation. So obviously decreasing the number of defects found in production, finding them earlier in the life cycle by left shifting, deploying faster, and also deploying more frequently, and that's not displaying quite right, but in this case they got up to 26 releases to production per year, and that's actually what we at Dynatrace can also do. If we take a look at an example of what we can do in a DevOps pipeline, and regardless of what you're using for automation, this could be the case, right? So a build happens, and we deploy out to the staging environment, and now we're gonna run some automated testing using whatever tool you have for that. Dynatrace can be sitting under the covers watching that environment and understanding what's going on, discovering problems that maybe your testing tools are not gonna discover. After the test is done, you can have your tool call into Dynatrace using our API and find out where any problems discovered in the environment, and if that's the case, we can automatically reject that build. And the great thing is with the information in Dynatrace, we have the ability to give your development team all the answers they need about what happened so they can make that better. If we're talking about going to production, maybe we deploy over the weekend, we can have your CI/CD tool update Dynatrace about the information about what was deployed, what exact versions, so that maybe on Monday as things start to spin up and users are coming in, and if there are any problems discovered, Dynatrace can fire a problem out to something like Ansible Tower, and it can figure out what to do for remediation, whether that's going to be rollback or maybe deploying some more hosts to get some more CPU around a service or what have you. All right, Dynatrace does this with our tremendous high fidelity data coming in through our one agent. We understand your applications, we understand the transactions through them, we map them end to end. All of that information goes into our deterministic AI. And the result is when problems are discovered, we're able to tell you exactly what the problem is, how your users are impacted by that, and exactly what the root cause is, so you do not have to spend time in war rooms. We would love to talk to you more. Please stop by our booth to talk about Dynatrace or Trip Shakespeare. 1 second left.
Right on time. Thank you, Dynatrace. And Bridget will be coming up shortly as we continue our program. Stop in again at the sponsor hall. Register your name for one of those fabulous raffle prizes that'll be offered at 3 o'clock. Thank you.
Thank you again, Debbie. Remember, sponsors are why this is here and affordable. All right, so for our next talk, and this is, again, you probably noticed that we have pretty in the weeds, like, hardcore tech topic, et cetera, today. And Serena's talk is no exception. If I can welcome Serena Titi to the stage. What I'm really excited about here is, again, hearing from someone who works in our local community at one of our local employers and sponsors of this event. And come on up. We're going to talk about, and I'm very excited for you to talk about exactly how you get into the details of the stuff we all need to do. So can you give it up for Serena Titi?
All right. So, one, I can't believe everyone in the approval process let me get away with this title. But yeah, I'm super psyched to be up on stage for my first time. I'm Serena. We're going to talk about how UHG does security logging. And I want to thank all of the organizers, sponsors, volunteers that make all of this stuff work. Shout out to the AV people. I had some issues with my slides this morning and had to fix them. All right, so who is Optum? Because some people aren't super familiar and aren't super plugged into the healthcare space. So kind of the short version is we're the technology healthcare services providers that make up United Health Group. Then you're probably more familiar with United Healthcare. That's the payer insurance bit. Then UHG, United Health Group, that's just the parent company. And then about me, interned at Optum back in 2016. Started full-time after I graduated in 2017. First rotation came in through the technology development program, so you do 2 6-month rotations. It's kind of up on Tier 2 help desk, doing password resets, provisioning user accounts, learned a lot of empathy for the underbelly of IT. Then another 6-month rotation, ended up working with Heather Mickman's group, where I was doing Kafka Streams development. Then I got super into Prometheus because we were having issues with our streams. And at the end, one of the people's like, oh yeah, you did good SRE work. And I'm like, that's the word for what I'm doing. Awesome. Then when it came to final placement, my old boss, who I worked with during my internship, said, hey, come back to security. We're doing a bunch of Kafka stuff, and we need to get off the ground. And I said, launches into this whole, very long spiel, and I kind of said, I was sold 5 minutes in, but it seemed rude to interrupt. So kind of my whole thing is platform developer, SRE, alphabet soup job titles, but I prefer just plain old vanilla sysadmin. There's nothing dirty about it. I keep the lights on, and that brings me joy. So, like all engineering endeavors, what problems are we actually trying to solve? Define them. So we had long log ingest times. It took tens of minutes. Sometimes jobs would fail. And it just took a while. And someone said, could we make it faster? Yes, we can. Inconsistent log formats. The old process, probably touch on it later. It used to be you get into a queue, have people write custom regex parsers, and there you go. And then some of the smart connectors just do their whole thing. Except, believe it or not, people writing regex doesn't scale when you're at hundreds of applications. And sometimes the log format might just slightly change and break all your regex. Also vendor lock-in. We kind of got like commercial logging system, and it was kind of hard to get data out of it. And we're like, oh, let's see what we can do about that. So kind of outline for today. I'm going to talk about your enterprise-wide log schema and how to sell that, because boy, asking people how to change their logging is difficult. Then we'll dive into real-time, near real-time, depends how you want to define time. After that, go over how a small team of few people, because we used to be 4, now we're around 8, thankfully. Go over everything, we stood up everything, and then give you some tips so you can learn from my mistakes. So we got our schema right up here. We got 8 required fields, but we have a bunch more, but these are our bare minimum. So device.vendor, that's if it's your in-house app, that's gonna typically be your company name. So for me, yeah, it'll probably be Optum. Then your product, what's your application called? So another example is I'm actually collecting logs from my own Kafka platform. So vendor, all right, that'll be Apache. Don't have a vendor relationship, but close enough. Device.product, Kafka, Zookeeper, etc. And then host name, just host name, plain text, pretty normal. Device IPv4, now this is where it gets a bit interesting because we used to get weird dotted decimal parsing issues. So we just said, okay. Convert it to the long integer format. Not a string, just give us the raw number that the computer actually cares about. We'll convert it for our analysts later. And then a couple of validation rules. Don't set us 0.0.0.0. That just tells us you're binding to all interfaces, which, yeah, you typically do. And that gives us 0 context. 127.0.0.1. I don't care. Localhost, local to whom? Timestamp. We do milliseconds after the Unix epoch, because we used to get weird timestamp formats in all strings. Some people don't feel like putting time zone offsets. Why? So we just kind of said, okay, fine. Give us Unix time. We don't care about time zone offsets now. Message, human readable string. Describe what's going on. And then application ID. So we have an internal database we use at UHG just to keep tabs on all of our apps. It's mainly used for like billings, chargebacks, etc. But for our use case, since every application has a unique ID, we get to keep tabs on them. And then when they start sending us bad logs, we get to go and say, hey, could you make a couple small changes, pretty please? And then application.name, more the human readable name that's just up in our CMDB, config management database. I'm pretty sure everyone's got one of those. And I forgot to cover at the beginning, so, because we get asked this a lot, what is an actual security event? And things we're mainly interested. We want logins, log-offs, session expiration. Give us the query that's ran on a database. Don't give us all the data, because some people say, well, this returns like 1,000 results, and it's like, no. Keep the logs nice and small. We're shipping it over the network. API calls. And basically, these are the bare minimum that you need for your security analyst to actually make sense of what's going on. Obviously, have more, like response codes, like the actual API endpoints. That'd be all great stuff to have. And then, why you want a schema? So, like I said earlier, it's hard to parse infinitely many formats. Like, I'm getting our Kafka and Zookeeper logs. Yes, I wrote a ton of regex. I got real good. And, yeah, it's not fun. So we're just kind of telling people, doing the whole shifting security left and just say, please log our way. Please, pretty please. So it's all nice and standardized. And kind of the issue is, like, now we're trying to get the whole company on the standard or structured logging train. And the issue is, gonna be honest, I'm writing my automation stuff. I don't think about logging. I rarely think about logging. there to help me out, try to figure out what's going wrong with my app. But main thing, it really helps your security folks actually have like a common enterprise-wide schema. So like every event looks pretty similar beyond like your typical message fields. Now, Avro. We use Apache Avro because I like me some data compression and the encoding, hard schema. So when people send us stuff that doesn't conform, we just say, well, you don't meet our schema, goodbye, off to dev null you go. Sorry. We used to take in whatever stuff people sent us, and it turned out, yeah, it's kind of hard to make do real good alerting use cases off of those. And then, since everything's nice coming in standardized, you don't have to do a whole lot of cleanup. It doesn't necessarily mean the data coming in is high quality, but, well, we haven't quite automated that bit yet. But everything's coming in, it's looking good. Now, all right, so you go up and say, all right, yeah, hey, your security folks go up to your developers and say, yeah, I want you to log our way. Okay. And, oh, and by the way, if you don't conform to our schema, we're just going to drop your messages. Okay, so you're asking your developers to do a lot of work. And yeah, it takes time. So being security, yeah, we get to go out, make a security policy, made a change, and say, yeah, developers, you must log this way. But on the flip side, with a whole kind of heavy-handed mandate like that is, you do need to acknowledge it takes time and help them out along the way. So a couple slides, next couple, I'll have some screenshots of the tools we're using to kind of give some feedback to our developer community. And, but yeah, again, be really patient. This stuff does not happen overnight. And we've had to make some exceptions and meet people in the middle. Like, for example, I didn't know mainframe applications don't have IP addresses. I cannot believe that that's a thing. But again, I'm not a mainframe developer. They also don't have they don't have Unix time. There's no nice COBOL statement that just gives you that. And coolest thing I saw, and I kind of want to get access to their source code just to look at it, we had COBOL people say, okay, fine, we can do structured logging. We'll write out all the string handling to log in JSON in COBOL. I am both amazed and slightly terrified of mainframe developers. That is super creative and awesome. So one of the things, we had one of our devs. I don't know if Kyle's watching at this time, but shout out to you, dude, because this validator is amazing. So people are saying, hey, how do we actually know if our messages are valid? Well, you're doing your development. You're just going to go, print off a couple log messages, copy, paste, pop it in here, and we'll tell you, yeah, this is good. Send it to us. And then we'll give you a couple warnings. So like this is from my local development parsing out my Kafka logs, and yells at me saying, oh, your host name doesn't resolve over DNS. Well, it's a local machine running on my own thing, so yeah, 100% expected, but it's very helpful. Then we got our customer view. So giving access back to security data is a little, because we're having everyone come in, go into a common topic. We're looking to change it, give everyone their own topics. It's a little hairy. So ideally, right now, our current solution is, yeah, look, we can give you the counts, but we can't actually show you the text because we lack the means to give fine-grained access control. We're working on it. It's on the roadmap. And this is just, again, coming off of our validation streams and kind of telling people, like, hey, if it passes the validation stream, we got it. You don't got to worry about it after that. The rest of that, that's an us problem. Now, streaming, why should you stream your logs? So being security, I love thinking of the worst possible things that can happen. So should the worst happen, heavens forbid, it doesn't happen, an attacker popped your box, got root on it, and is like going messing up all your services. And sure, you can't stop them from logging, but if you're streaming them off the compromised endpoint, you can at least get your whatever data essential log data is on there before they shut that off. Or even if they don't know what's running. You get to watch and see, oh, yep, that's 100% an attacker. Let's go shut that down. And then another thing, streaming real time. If you start noticing something weird going on and your people in the SOC are saying, yeah, there's something up, you can lower that time to detection nice, get that down, save the day, get a nice, there you go, from your head, and everything's great. Good guys win and all that jazz. So, Kafka, super basic. We're all using this. There's no secret sauce. This is just kind of the way that we're doing it. Super common, it's resilient, set your replication factors good, and it's got some pretty good built-in resiliency, even though I'll cover later that, yes, it's resilient, but sometimes you might have fun Kafka gremlins, like I've been dealing with this week, because they love to act up whenever I'm away. And then the other nice thing is, why I like Kafka, the docs are amazing. Everyone and their moms has written a blog post on data streaming with Kafka, which is great, because when you're a newbie operator like myself, and I'm like, I don't know what I'm doing, but the collective wisdom of the internet just says, oh, here's some sane configs, or you kind of go with the inner source route, and there's already a group of people running Kafka, and you just say, I may or may not have borrowed a couple and just forked a couple Ansible roles. Because be super lazy. And also, so far, we haven't hit anything in scale. I was kind of sarcastic. I'm like, whoa, we have a whopping 1 megasecond going through right now. We'll hopefully be getting more, but we're kind of just started out and getting our stuff stable in production. Then, again, finally talking about how do people actually send us logs? So we got a couple options that you and the whole family will enjoy. You can just send them straight to our Kafka topic. We're a pretty heavy chef shop, so we just kind of wrote up. Again, Kyle wrote up a chef cookbook, and it's like, oh yeah, we'll install FileBeat. And yeah, just plop your logs in this directory, or you can go use our attribute manager, set your log directory, make sure it's formatted, we'll take care of it from there. Also, we're pretty heavy Java shop, so we had, again, since we were pretty small, we had kind of one of our internal teams, kind of think contracting, but, internal, and kind of commissioned hey, could you guys build us like a nice little Java package? So people can just call all of those methods and build our logs and just give them a send method. And then again, and it'll handle like IP address conversion, you've got your epic time in milliseconds. We'll have to revisit that in 2038, but that's a long ways away. And then finally say, well, I don't do Java, and I need a little more parsing than FileBeat can give me. That's just fine. We don't really care. Send it to our normal direct producer topic. People say, hey, I'm supporting a vendor app that's just off the shelf. I can't change this logging source code. That's fine. We personally recommend FluentD. For my use case, I needed something super small, lightweight, that had some heavy parsing capabilities, and due to our constraints and the pain of installing Ruby, I said, okay, I'll just use FluentBit. Just again, write out tons of regex, it'll be fine. And whatever heavy lifting I need to do, Google can teach me Lua in a few seconds. Then Kafka Streams. I love the Kafka Streams API. It's super nice and fun to work with. And basically, nice thing Kafka, it's just a message queue. That's all it is. It's super small. It's super basic, but there's a lot of cool things you can do to it. Multiple producers, different consumer groups. So, and then, we start getting our data nice, fast, snappy. And, this has lowered our latency in the orders of tens of minutes, and now we're down to trying to think of the actual empirical numbers, but 5 or less. And then, again, really hammering down on this point. Lower your time to detection. It'll be great. Get those alerting use cases, analytic streams. Awesome, I support that. And then most of our stuff runs in Kubernetes because I manage multiple virtual machines. I dislike and don't wish I didn't have to be on virtual machines because you can mess something up weird with a state. But thus is the way of life with stateful workloads. And then kind of our streams kind of just fell into the microservices architecture. We got one, do the validation. If that reports that, hey, your stuff passed our validation, as far as the developers are concerned, that's it. That's your responsibility. The rest of it's on my team. Then we got another one. We got a nice big security data lake. We run a bunch of analytics on all of our endpoint logs because you got your firewalls, switches, network appliances. They're all quite noisy. So we got our validation. Then we got our Elasticsearch and our data lake. We got Hadoop, HDFS. So it's like, all right, one, go put your stuff into Elastic. The other, go write it to Hadoop. And people will start messing around with Spark, and we'll see what cool things we can do. Now, this is the section of do as I say, not as I did. So I have to operate in my organization's DMZ. I can't talk to the public internet. So fortunately, we got some basic, we're running RHEL. We got some nice servers that have the base system packages. But unfortunately, they can't just say, oh, yeah, just yum install Kafka. It'll be fine. So interesting thing is, so we have a vendor product that kind of mimics the S3 API, which turns out has both a DMZ and a core endpoint. Awesome. Mess around and, oh, great, I got my whole Yum repo up in S3, accessible in both core and DMZ. Amazing. Got to package the stuff myself, but hey, I'll take it over a tarball. So, order of operations, going back to the DMZ, this stuff matters. So, do your bootstrapping, non-Kafka stuff like base playbooks I run. I'm going to provision some TLS certs, set my time zone to UTC, install node exporter. Personally, I'm a Prometheus kind of gal. That's just what I learned first. Then, got to add the node to your firewall rules first. Traffic won't be going to it because Kafka's not installed, but it has to be in your rules. Then you can add it to the cluster, and then optionally, oh yeah, go and rebalance your partitions. Make sure to spread out that load. Because I accidentally switched the steps because I added the node to the cluster, rebalanced, and I was like, I can just wait. It's not like I'll be a leader of partitions or anything. Oh boy, was I wrong. I learned that mistake the hard way, and then clients were all complaining, hey, I can't talk to the leader of this partition. When I'm like, looking at my dashboard, it's like, what do you mean? And the cluster's up and, oh, firewall, neato. All right. And then kind of package up everything nicely. RPMs are great. I recommend there's a great old plugin I'm using called Nebula's OS package. It works great, super simple for me to use. Then infrastructure, change management. Kind of gets into some interesting bits where, I'm supporting a health insurance company. So believe it or not, our peak season, got your Medicare open enrollment, individual. Everyone loves that end of the year where you're signing up for your health plans and you just want to tell the employer, hey, I just want the one I had last year. But however, since peak season, we value stability, and things are maybe a little difficult because we got change blackout dates and working around odd hours. So big thing is, just do as much as you can outside of that time, because I was trying to set up all this infrastructure during our peak season, and it took a little while. And also, try to, build in observability. Perfect, next point. instrumenting all the things. This isn't a super pain point. Well, actually, no. I was kind of trying to say, all right, got to ship out features, get the cluster stood up, get everything working, and then realized I have zero idea what my Kafka cluster is doing. Okay. And there was a whole sprint where I was just like, all right, I'm just getting metrics. I'm gonna go grab Node exporter, JMX exporter, get a Prometheus out in the DMZ, get it all added to our Grafana instance as data sources, and it's like, great, I can see all the health, everything looks good. Now we're getting logs out of our platform stuff, so we're running, again, Kafka, Zookeeper, Confluence open source schema registry to handle all of our Avro and make sure everything's nice and compatible whenever we make changes. We're also getting logs from our attribute manager because, yeah, we sure would love to know who is changing log directories on people's boxes. I think that's kind of all we're collecting right now. Still working on setting up, tracing, see what people see. Cool thing is, we inadvertently kind of rolled our own. Not super great for tracing use case, which has more details, but we have a heartbeat generator because we're all talking about, we want to see, hey, what does the customer see when we write messages? So I think it's like every 5 seconds. Testing. And it sends a message through. We set up a watcher in Elasticsearch. Most of the time, I got my message in a 5-minute period. I'm happy. Sometimes it says, oh, I am a message short, which normally means, it just took a little while to get through. Being a small team, what a blessing and a curse. Because it was nice, and we used to all be out in Minnesota, but now we got, we got some people out in Colorado, we got people out in Maryland, now Carolina, because big global company, we're all distributed everywhere. But we all can talk to each other, like, say I broke the Kafka cluster, and, can say, hey, I think something's wrong. However, be realistic with your expectations. We used to be, again, only 4 people. We just said we can't realistically do an on-call rotation. Like, yes, this is super important, but we're just not adequately staffed. Because if we're all on call, then yes, we'll all burn out, and then none of us will be keeping an eye on the platform, and then that's just worse than no support. And then automate everything. I'm super lazy. I was thinking, okay, I can just go hand patch and looking at my inventory list in Ansible and say, oh dear, that's 40 servers. Yeah, no, okay. Code is gonna solve that. Big thing, no is a complete sentence. Everyone you got someone saying, hey, important person, hey, I want this feature in like right now. And it's like, hey, we're working on some stability stuff, trying to reduce our tech debt, paying that down. And it's like, hey, listen, we hear ya, and I know we have a lot of people, dev community saying, hey, we want like some limited access back to our logs. And it's like, yep, we hear ya, we got that feature request in loud and clear. However, gotta have your manager, your boss's boss, and boss's boss's boss, say, yes, I respect this team's autonomy. So depending on where you are, your mileage may vary. Then final thoughts is, so in college, my professor, when I took digital signal processing, it used to be, once upon a time, I was thinking, yes, I'll be an electrical engineer and do embedded systems. He always concluded every lecture with, so these are the main points that when your mother asks you at the dinner table what you have learned today, this is what you've learned today. So this is what you go back, tell management and your team. Enterprise-wide schema, and acknowledge that, yes, it will take time. There will be pushback. 2, stream everything. We've gotten a lot more network bandwidth now, and as such, we've all kind of gotten accustomed to I want that web page to load up right now. Similarly, yes, I want that log data right now. And then be patient. Get your devs involved. Like, actually, we kind of started doing the inner source thing, and we actually got more devs kind of looking at our Java package and saying, hey, this was a good first cut. Here are some resiliency things, and hey, are you open to a PR? Yes, I love a PR. Or also on our schema, like we have people, you want a feature request? We're on Git, we have all of our repos public on our internal GitHub Enterprise instance. Come talk to us in our Slack channel. We don't bite. If you have questions, please ask, because we would much prefer you to ask a question and to get answers so you can log better. Then, we all win. Kind of the main thing is, it's DevOps days, and also as someone who's kind of development, operations, and security, it's kind of nice to realize that, yes, we all should be friends. We're all on the same team. No one wants to be in the news. That's, that's the thing. Can't be in opposition. We're all, on the same side here. And then, kind of some links. So, if you're looking at this on GitHub, I put the link out on Twitter last night. Got a PDF, which, PSA, if you're using Reveal.js and speaking at a conference, export to PDF. Do yourself that favor. Speaker notes, Twitter, I'm at Serena TD. Yes, that's how that last name's pronounced. I love weird German last names. GitHub, Lady Serena. Thank you, everyone.
All right, gotta get the 2 mics just to make things confusing. Thank you, Serena, that was fabulous. Once again, it is time for our sponsors. This is our last round of sponsors, so stay seated. And first up, we have Chris from CodeFresh.
Hello, everyone in Minneapolis, DevOps Days. How are you all doing? Good stuff. I'm from CodeFresh. We are a Docker and Kubernetes native CI/CD platform where every step in your pipeline is its own Docker image. Any Docker image you need for any situation. So mix and match the tools you need to make your pipeline happen. We can connect to any cloud-based service that you need, whether that's your different GitHub, GitLab, whatever Git repo you use, whatever Kubernetes cluster you use. And yeah, we can work with it from start to finish. We're built from the ground up to support microservices. So go ahead and head over to codefresh.io, sign up for a free account, and with unlimited builds, and go to town. And if you haven't already, swing by our booth in the corner, or go to bit.ly/MSP-Legos to get a chance to win some Legos, because who doesn't like Legos?
All right, thank you, CodeFresh. Next up, we have Mara from Google Cloud.
Hey, good morning, everyone. My name is Maura. I am a user experience researcher here with Google Cloud. As a born and raised Minnesotan, I'm especially excited to be here. But on behalf of everyone here with Google Cloud, we are really stoked to be supporting this wonderful, unique community. Thanks, everyone, for coming by our booth so far and sharing your questions, your experiences about SRE, DevOps, and Google Cloud. Practicing DevOps is about the right set of tools and the right set of systems to be able to set yourself up for success and innovate in a constantly changing world. At Google, we believe that we have the right set of tools, features, systems to really help you succeed and to do that. And we also really care about your organizational success, but also about you, the practitioner, and your experience along the way. Whether you are a Fortune 50 company or a group of fortunate 50 people who are working together to change the world, please stop by our booth, share your questions, your experiences, your challenges with us, and let's talk together about how we can build amazing things.
All right, thank you, Google Cloud. Next up, we have Anna from Target.
Hey everyone, I'm Anna, and I'm the developer advocate at Target. We believe that our technical community is the key to our success. So I have a full-time job at Target working for our developers to help create the kind of community they want to work in, but also the kind of community they want to be a part of in the Twin Cities. It's pretty cool, actually. So that's why we're here. That's why we're sponsoring DevOps Days Minneapolis. And we're really excited to be here. If you are interested in looking at joining our community, please visit our Target booth and chat with my friend Pat. Have a great day. Thank you.
All right, thank you, Target. Next up, we have Kelly from Sumo Logic.
Hi, good morning, everyone. I always feel like this becomes that point in time where I feel like I'm an old episode of the dating game, and they say, sponsor number 5, if I were a potential prospect, what could you do for me? This is my 5th DevOps Days in Minneapolis here. I've been to DevOps Days in Nashville and Chicago, in Iowa, in all sorts of different places, and hands down, the Minneapolis DevOps Days is always the best. So I just want to put that out there and just say to everyone in the room, I mean, it's such an awesome culture here. It's so cool to be a part of it as a local. We at Sumo Logic are a native cloud-based machine analytics data platform. That means logs, metrics, things like that that are going to give you insights to what's happening in your stack, in your environment, whether that's on-prem, in the cloud, Kubernetes, 3-tier, even in the monolithic world, helping teams and folks out there in that capacity. We've got a Sonos One Alexa-enabled speaker, so another thing in your house that can be listening to you potentially if you're interested. So stop by the booth and come talk to us. Thanks, everyone.
Thank you, Sumo Logic. Next up, we have Pepper Data. It's Patty from Pepper Data.
It rhymes. I changed my name just for the job. So with me today is my colleague Eric, and no, he's not going grocery shopping. We wanted to call your attention to our booth where you'll see the Count the Peppers contest if you haven't done it so already. Come by, take a guess at the peppers, and you could win a Mach 1 drone. And we also have a couple of other gift cards to give away as well. So Pepper Data is really pleased to be part of DevOps Days here. You all have a great community. I've been to many of these, and this is a fabulous group of folks. Pepper Data does performance management for Hadoop and Spark. So all of you with Hadoop and Spark workloads out there would love to talk to you. As our last speaker, Serena, mentioned, instrument everything. We do that in the cloud or on-premise for your big data and Hadoop workloads. So come by and see us. We have a drawing at 2, and then we have another one on the big stage at 3 for the drone. Thanks all.
All right, thank you, Pepper Data. Next up, we have Tyler from Jump Cloud.
Hey, everybody. I am an account executive at Jump Cloud, the dreaded AE. But here to just tell you a little bit about our service. We allow you to authenticate any IT asset that you have, regardless of the vendor, no matter where they happen to be, securely. And we do this by supporting a number of pretty standard authentication protocols, being LDAP, SAML 2.0, Radius, as well as RESTful APIs. And on the system side of things, which is probably more valuable for all of you guys, we do also allow you to authenticate and manage Mac, Windows, and Linux endpoints. So we can manage and store your public SSH keys, allow you to push out policies and commands to a fleet in AWS, in Azure, or wherever it happens to be. We do also allow you to sign up for a 10-user free account that's fully featured and fully supported. So you can go and actually see exactly how Jump Cloud is going to work for your business. And if you have any questions, feel free to reach out to us. Our booth is in the back. Thank you.
All right, thank you, Jump Cloud. Next up, we have Jody from Chef.
Hey, y'all. As she said, I'm Jody Wolfborn. I work at Chef Software. I just want to take a moment and can we all give a really big round of applause to the organizers of this event? You guys did awesome. I won't waste too much more of your time, except I do want to tell you to head over to learn.chef.io if you want to go through and get a little bit of training there. And we're also about to kick off a road trip around the US, so we're going to be evangelizing DevOps practices and stuff across the US and also in London. So yeah, check us out. Keep an eye out for the LCR road trip and come talk with us at our booth.
All right, thank you, Chef. Next up, we have Rick from New Relic.
Hi, everybody. Rick with New Relic. Thanks for having us today. Show of hands, who's invading Area 51? Anybody doing that? 2, 3? Don't do that. Some advice from Rick and New Relic, don't invade Area 51. But if you do, stop by our booth. We have a Area 51 survival kit, some wireless headphone speakers, backpack, and a water bottle. You're gonna need it. But all kidding aside, I got 30 seconds here, they're gonna kick me off. New Relic at its core is an observability platform, and it ingests data and helps IT teams really foster a sound IT management process in order to create not only better software, a better internet, but better business outcomes. So please stop by our booth, and I'd love to talk more. Thanks, guys.
All right, thank you, New Relic. Last but not least, we have David from Microsoft.
Hey, everyone. First of all, thanks for coming out. I simply love the DevOps community and how much we're pushing it here in the Twin Cities. Let's be honest, we all have our own favorites, we have our own clouds, we have our everything, right? And so really what we're trying to say here is we are an ecosystem that allows you to plug in whatever it is that you already use to be able to collaborate, code, deploy, etc., all within one umbrella called Azure DevOps. If you haven't played with it, I would strongly suggest it. And talk to a number of different companies, CHS, et cetera, that I've seen around here, who's already been using it in different ways, not just with just Azure DevOps, but things like Chef and Octopus Deploy, things like that. The other thing I would say, 6 seconds, my goodness. The big thing there is it integrates Campfire, Slack, Treco, and more. Plus, you can add your own customization into it. So come check it out for free.
All right, thank you, Microsoft Azure. And let's give it up again for our sponsors. This conference wouldn't happen without them. Thank you.
Okay, awesome. So you have one last chance to go to the sponsor hall over lunch, and then you'll be in at the lunch or the afternoon break, and then you're getting that drawing and winning everything. That's the plan, right? Everybody here is going to win everything? Okay, good. So our last speaker, our closing keynote, I am super, super, super excited about. I might jump up and down. I would like to welcome Alice Goldfuss to the stage because everything that she has to tell you is hard truths you have to hear about all of the tech trends that you might be excited about. All right, please welcome Alice Goldfuss.
Hey everyone, hell of a conference, right? I am so thrilled to be here, framed by this fantastic bisexual lighting. Feel like I'm in Atomic Blonde. I love it. Today I want to talk to you about the Container Operator's Manual. And if you want to talk back to me about it, either about the bisexual lighting and the containers, these pants, what have you, you can reach me on Twitter at Alice Goldfuss. I will be there for most of your needs. Speaking of me, who am I? Well, I'm Alice. Nice to meet you. I am a site reliability engineer at GitHub, which means I'm a professional warrior with pseudo access. This is the best photo of me ever taken, so I use it for everything now. And today I want to talk to you about car ads. Now, you know when you're watching TV, and by that I mean you know the 5 seconds you're waiting for the skip ad button to come up on YouTube, and it opens up on this beautiful, picturesque countryside in a mountain range with a serpentine road snaking in and out, and there's this sleek beast of a machine just raging through, and as it's going, there's all these stats popping up, like 0 to 60 in 5 seconds, 70 miles to the gallon, 5-star rating, and you're sitting there going, yes, science has proven it. This is the perfect car. If I buy this car, I will have achieved perfection. And if you happen to purchase that car and take it out into the field, you will realize that you are actually achieving much different things. And if you look at the bottom of the screen in really small letters, you may notice the phrase laboratory setting. Laboratory setting, because it's a car ad. And those facts and figures are basically one step away from theory. And were you to actually get that car and take it out into the field, your experience would be a bit different. And that's how I feel about most container talks. Because typically you go to a container talk and someone comes out and they say, step right up, step right up. In the next 20, no, 10 minutes, I will tell you everything you need to know to revolutionize your production platform and run containers in prod. What's that? You want to run more than one container? Well, no problem. Just download this gist, don't read it, run it on your laptop, and in 5 seconds you will have a 3-node cluster perfectly tuned. And you want to run containers in prod? Well, go right ahead. After all, prod is just your laptop times 100, right? Great, thanks, and they walk off. And you're staring at this half-finished tutorial thinking, is this why sysadmins are so mean? Personally, I would like to see a lot less Docker 101s and a lot more Docker WTFs. Because there are just some things as an industry that we need to talk about concerning containers, and that's all I want to do with you today. And you might think, all right, sounds great, but why should I listen to you, Sinead DevOps? Well, I have been running containers in production at scale since January of 2015. And in 2016, I moved to a team that ran Dockerized Cassandra clusters. And now I'm on the team responsible for the Kubernetes platform underneath github.com. So I've been running containers in prod for about 4.5 years, and if you consider that Docker came out about 6 years ago, that's really not bad at all. So before we begin, just to make sure we're all on the same page, I want to cover what is a container. Because have you ever been to one of those Container 101 talks? It probably went a little something like this. First, you have your host, and it's a box. And on top of that host, you have your operating system, also a box. And running on top of that operating system is a container daemon, a box. And then inside of that daemon, you have your containers, which are smaller boxes. And this is great, it's fantastic, except that it's all lies, every single piece of it. I mean, this is what containers look like to humans, but this is what containers look like to a computer. This is the top readout from a production Kubernetes host, and we see some processes running on it. So let's take a look at them. So third down, we have Dockerd, which is that Docker container engine. Fifth down, we have the kubelet process, which is a Kubernetes process. And then we have some Ruby and Python processes. And those Ruby and Python processes are containerized applications. They're right there. They're not hidden in a box. They're not abstracted away. They're just running as processes because that's what containers are. Containers are processes born from tarballs, anchored to namespaces, and controlled by C groups. So talk over, you're done, just go. What does this mean? So there is nothing in tech, there is no concept of a container in the Linux kernel. There is no flag that you run when you're compiling GCC-C. That's not a thing for containers. Containers are just native Linux features stapled together. I guess this is more of like a nail gun. They're nail gunned together. And they don't actually exist in like a concrete concept. So let's dig into that a little bit. When you are writing a Docker file, or some kind of container spec, you are coming up with an instruction set, a recipe for how you want that process to run, defining the directories, the dependencies. And when you build it into an image, you are creating a tarball. And when you deploy it to run, that tarball is getting unpacked and being run as a process like any other. Now here is where those native Linux features come in. The first one is namespaces. Namespaces determine what a process can see, such as other processes or directories, not everything on the host, just a slice. And to that process, that is everything. And the second feature is C groups or control groups, and those determine what a process can use. Resources like CPU cycles or memory, and together they make a container. This is a container. This is what people want you to run in prod. And if you're thinking, oh, I don't know about that. I thought it was like whales. Well, don't worry. We are going to take a nice hard look at what it means to actually run containers in production at scale. And by the way, yes, the vast majority of my background is in bare metal deployments. I know things are a little bit different in the cloud, but just because you think it doesn't apply to you doesn't mean you can just throw it out the window. This isn't the Linux kernel mailing list. So we're going to be talking about 4 lessons. Starting off with containers have strengths. I don't want you leaving this talk going, that Lilith's Fair reject doesn't like containers. I like containers. I just think you need to run them in the right way and play to their strengths. And containers' strengths lie in stateless applications. Now, again, what do I mean by stateless applications? A stateless application is an application that takes data in, changes it in some way, and then sends it out on its way. It doesn't keep any data for itself. It doesn't tick a counter. No state is changed. It doesn't know where that data is even going or what it's doing afterwards. It just takes it, changes it, and moves it along. And stateless applications are fantastic for scaling your infrastructure because you have all of these instance clones running side by side, and if one of them goes down, the dependencies don't care. And the other instances don't care either, provided you have enough headroom with load balancing, whatever, we're all adults. And it's in these ephemeral, disposable processes that containers shine because containers themselves are ephemeral, disposable things. And so if you have stateless applications or microservices or whatever in your infrastructure, I encourage you to consider containerizing them. And just as a note, containers are not magic boxes. My boxes are okay because we know they're lies. So, what are these strengths I'm talking about? Well, first of all, once you've gone through the rigmarole of figuring out what your process needs and you've delineated all of the directory structures and dependencies, that container is very portable. If it runs locally, it'll run on your Linux production environment. You can put it anywhere. And that also means it's extremely easy to upgrade. You just have to change a code commit or change a dependency version, build it, roll it out. And that also means it's extremely easy to iterate. And if something goes wrong, you don't have to have a huge rollback plan. You just have to deploy the previous image version. Much shorter run book. Excellent. Now, you can get all of this from a blog post. You can get this from one of those Docker 101 talks. Let's talk about something a little more crunchy, like disaster recovery. Who here has had to deal with disaster recovery? Yes, we are all recovering from our own personal disasters as we speak. Typically, when you start hearing the words like FedRAMP, like, yeah, that's when you have to care about disaster recovery. Who here has had a disaster recovery exercise that looked a little something like this? Where you're sitting down to figure out how to deploy all the applications, and if you find out that this one deploys with Jenkins, this one deploys with Capistrano, and this one deploys with a cron job running off someone's laptop every day at 3 a.m., and were they to quit, you'd be in big trouble, hypothetically. And then like the day of the exercise, you're there deploying something, and it turns out the dev who wrote down the instructions missed something, so I need to go find them or someone else from their team, and it's taken forever, and the auditor's like, tick, tick, and they're like, yeah. Meanwhile, if things are containerized, they are all being deployed to the same place in the same way. And having been on the Capistrano and container side of a disaster recovery exercise, I much prefer it over here. It's so much faster. And it's also faster for on-call. Has this happened to you? You get paged, you wake up, and you go, that is not mine. And now you have to figure out who it belongs to and page them and wake them up, and it takes even longer. Well, if both your services are containerized and you get paged by mistake, you can at least try deploying their service for them. Sometimes that's all that's needed. And if that fixes it, guess what? You just solved an incident in less time with less people, and now they owe you one. And I have also done this, and it's great. Containers are also good for testing environments. Because what is a testing environment if not some place where disposable ephemeral things happen and then clean up afterwards? No artifacts. For some of you who may be writing desktop applications where your production environment is someone else's computer, this is where containers can really help you, because you can run different versions of your desktop application in a testing containerized environment. You can say, ship logs, your test results to some centralized database, and then everything will get cleaned up at the end of the day. You don't have to soil your personal laptop trying to repro customer issues. All I'm saying is you have some place in your architecture that has disposable ephemeral things. Containers can really help you out. So if containers have strengths, it makes sense they would also have weaknesses. And if containers' strengths lie in disposable, ephemeral, stateless applications, it makes sense that their weaknesses would be in things that hold their shape, stay around, molded, like stateful apps. And whenever people talk about stateless applications and containers, they always want to talk about databases. They're like, yeah, I read a Container 101 post, and now I'm just going to throw my databases into a container. It'll be great. Okay. And whenever they say that to me, I like to say, are you Google? Now, that tends to hurt some feelings, because what they're hearing is, are you a success? Are you a household name? Have you had a lot of lawsuits lately? But what I'm actually saying is, are you routing billions of requests to thousands of databases across dozens of data centers per second? Usually, the answer is no. I know for some people here it might be yes, but usually it's no. And in which case, you really don't have to containerize your databases. Now, I understand why you would, especially if you're on bare metal hardware, because you get faster provisioning, you get better stability, it's easier to fail over and recover. You've got dev teams working on features, and they want a database now, and you have to put in your hardware order and wait 3 months for Dell to even wake up and get it to you. I get it. I get it. I understand why you would just want to spin up a containerized database. But have you considered that you can get all of these things with some tooling and the cloud? And when I say that, people go, do you have any idea how much money that would cost? Apparently, it would cost more than hiring your own database container platform team, having them research and build it out for you, and make sure they know how to contain and secure all that data. Sure. Because you're going to be dealing with a lot of data. And do you really want to be putting money and resources into building and maintaining a platform that isn't even the main part of your business? But some people do. And when they do this, they go about it in usually 2 main ways. So let's talk about that. The first way they do is that they have containerized database instances that store their data somewhere else in some sort of network-backed storage like Ceph. And so if one instance goes down, everyone's fine. And that instance comes back up and gets its state and starts sending data again. But the problem is, the more data you get, you will eventually become network bound. And if you're just dealing with lightweight databases that wouldn't be network bound, I don't really see the point of having containers. Okay. The other way people do it is they're running containerized database instances that store their data locally on the host where the instance is running. And now if you lose an instance, the data stays behind. So like, what do? Well, you can just regenerate that instance in place. And if you recall when I said I worked on Dockerized Cassandra clusters, this is what we did. It looked like a Cassandra cluster like any other, except the JVM was containerized. And yes, did containerizing the JVM make it easier to upgrade? Sure. Did it make it easier to iterate? Yes. Did we have to write a lot of custom tooling? Yes. Does it sound good on a resume? Yes. Was it worth it? Probably not. Another way people do it is, okay, that instance goes away, data is behind, generate the instance somewhere else, but now you still have to move that data, and again, you run the risk of becoming network bound. And if you're getting to the point where you're laying down dedicated fiber for your homegrown database container platform, maybe you should have gone to the cloud. But I get it. You want to containerize your databases. Okay. My only recommendation would be to keep it small. If you want to containerize a test database while the hardware is coming, that sounds great. Makes total sense. Allows people to work faster. If you have, say, an assets database where if it goes down, the website just looks kind of ugly, fine. But don't put your 16 terabyte customer account database in a container. You will be sad. And again, may I recommend the cloud? Because all of those providers have automatic failovers, scalable databases, read replicas in multiple regions. You get a lot of bang for your buck. And you might as well be taking advantage of vendors whose sole job is to provide this service. That leads us to lesson number 3, which is containers need friends. Now, typically, people say, oh, we're gonna do containers now. We're just gonna, roll out containers, no harm, no foul there, except it's never just containers. Containers are not one thing. Containers are a vast ecosystem of different software solutions that you need to research and stick together to create a platform. And there's different things you need to consider and research to get to that. For example, your dev setups. How are you going to be generating those tarballs? Are you going to be using Docker? I mean, it's basically tailor-made for local setups, but you don't have to run your containers in prod with Docker. You should look into that. Orchestration. How are you going to make sure that an application that needs X amount of CPU cycles and X amount of RAM runs on a node where that is available? What piece of software is going to determine that? Management. Are you going to have clusters? If so, how are you going to handle things like DNS or failovers or access control? Or are you going to have clusters that only run one kind of app or a cluster that's PCI compliant for security reasons? And networking. You're going to be adding new layers of extraction on this platform. How are you going to handle routing now? How are you going to handle access control? Can everything just talk to everything else? Can any person access any host? And how about service discovery? How is service A on cluster 1 going to access service B on cluster 35? You need to take a look at that. And just to give you an idea of what you're dealing with, here is an example of projects that handle networking in Kubernetes. And they don't all do the same thing. But sure, you did your research. Congratulations, you now have containers. You did it. Now you have to integrate that with your already existing platform. For example, deployment. How are you going to deploy to your new platform? Are you going to use the same tooling as what you currently are using? Or do you have to build something new? How are you going to maintain 2 parallel deployment systems? If one breaks, what takes precedence? What gets fixed first? Monitoring. Are there new data endpoints, new metrics that you need to consider to determine if a container or pod or cluster is healthy? Does your current tooling support this? Do you need to build new tooling? Do you need to buy new tooling? Do you need to train people on the new tooling? Provisioning. How are you going to provision your container hosts, your cluster hosts? Do you need to make any changes to your base images? How are you going to determine what takes precedence when it comes to ordering or your cloud budget, the current existing legacy stuff or your new container platform? And last but certainly not least, debugging. Now that you have a brand new platform with new layers of abstraction, how are you going to make sure that you understand it and can debug it when something's broken? And not just you, the infra people, but people running their services on your platform. How are you going to make sure that they can self-serve to troubleshoot their apps? And because you are going to be considering all of these things and doing a lot of research, you will be looking at a gradual rollout. And in my experience, on bare metal installations at medium to large size companies, you're looking at least a year. And when I say at least a year, I mean in a year, you will have kind of a platform and maybe one service running on it that no one really cares about. And you're going to need a year to get there, and it's going to be a lot of trial and experimentation. And at the end of the day, not everything is going to be containerized usually. Usually you're looking at a hybrid solution where some of your architecture is containerized and some of it isn't, like your databases, right? And you need to know what your actual goalpost is so you can set expectations accordingly. This brings me to my last lesson, and you can ignore everything else I've said. You can be like, whatever, I'm going to run containers on my phone, Kubernetes App Store download, whatever, I don't care. You cannot ignore this last lesson, which is containers need headcount. Usually, when people want to roll out containers, this conversation happens behind closed doors between two people wearing suits. And the first person says, "We need containers." And the second person says, "Let's give it to ops." After all, ops already owns inventory and provisioning, configuration management, networking, deployment tooling, monitoring, incident response, maybe security, maybe your databases. Let's put containers on top of that. I mean, containers are just like a new Jenkins, right? No, they're not a new Jenkins. Rolling out a new container platform is like building a brand new data center in a city no one's ever been to, with hardware no one's ever heard of, and software no one's ever touched. It is not a new Jenkins. It is a completely new thing, which means you need a completely new team, and you need to hire for that team. And there are a certain amount of skills that you need to consider when hiring for this team. For example, you need someone who understands operations, and preferably, you need someone who understands operations at your company. And yes, this means you can take someone from your ops team and put them on your container team, but you are going to backfill them on the ops team. You can't get that past me. You keep clapping. Do you want lunch or not? You want someone who understands operations at your company because you want to know where the skeletons are hiding and the snowflakes are running, because eventually, hopefully, you want to migrate them to your container platform, so you want to know what's coming down the pike. You want someone who understands deployments, both at your company and in the container ecosystem at large, and who has opinions about what you should be rolling out there and what would constitute a successful deployment and a good experience. You want someone who can write tooling, because even after you research and decide all your different container components, they are not going to fit together correctly. And they are not going to fit together with your systems correctly, which means you will need someone who can stitch them together. Monitoring. You will need someone who understands what a healthy container platform looks like, SLAs, SLOs, how to integrate those things, is really good with dashboards in a pinch. Someone who understands the kernel, because you're going to get some real weird interactions between the kernel and your container platform. You can count on it. So someone who can analyze a kernel crash, someone who can run benchmarks, someone who can go sifting through the seas. You need someone who understands those lower levels. Someone or someones who understands networking, because rolling out networking in a container platform is an adventure. There's multiple different schools of thought on how to do it. You need someone who can navigate those waters. Security. You need someone who understands security and how it applies to containers. Containers have a bad rap when it comes to security, but they have come a long way. And you need someone who knows what they bring to the table, where the gaps are, and what is important to you. And that person, incidentally, needs to be in the room when you are rolling out a container platform, when you are talking about it, not at the end when you're seeking a check mark because an auditor told you needed one. Security needs to be a first-class citizen on your platform. You need someone who can aid in internal adoption. You need someone who can walk up to a dev team and go, "Oh, that's a really nice roadmap. Oh no, it fell. Guess what you should be doing? Why don't you deploy your service to our janky-ass platform, watch it break repeatedly, and then tell us what we did wrong? Peaches, thanks." You need that person. Because if you don't have anyone migrating to your platform, you don't have a platform. And last but certainly not least, you need a project manager or a product manager, because internal product managers are a very important thing too. You need someone who can keep morale up, who can make a roadmap for you, who can have those hard conversations with leadership when you research something and it turns out that Istio, and you need to do something else. You need someone who can have those hard conversations, who knows that it's a year-long process at least and can keep the band together. Now, not all of these skills need to be an individual person, but they also can't just be one person. You are hiring a team. And I would say ideally it should be between 6 to 8 people. But at the very least, it should be 4 people. Because eventually this team is going to be on call for the container platform they just rolled out. And an on-call rotation of less than 4 people is untenable. You need at least 4 people. And once you've gathered them and hired them, you need to empower them to succeed. You need to write the checks for them to explore in a cloud environment while they figure out what the platform's going to look like. You need to be okay with failure, and you need to be okay with rearranging other people's roadmaps for that migration to happen. You need to set them up for success. You can't just put them in a closet and then later be like, where's my containers? You can't do it. You have to be working with them. So today, we took a nice look at what it means to run containers in prod. We talked about their strengths, which lies in disposable, ephemeral, stateless applications. We talked about their weaknesses, which is in stateful applications like databases and how you should probably just go to the cloud. We talked about how deploying containers is a vast ecosystem of choices and it's never just containers. And we talked about how you need to hire a complete team to run containers for you. But that doesn't really answer the question, should we use containers in prod? Well, I don't know. There are some indicators. For example, do you have stateless services? Do you have a large heterogeneous platform that you want to bring more in line? Do you have the time, the money, the people, the org support to pull this off? Then sure. Try containers. Why not? On the other hand, if you have a monolith and few support services, if your databases have pet names, if you have a small team with no org support, if people are just like, well, it's you and it's her, and you both already work here, so congratulations. Or if you just want to do it to spite me, then maybe don't do containers. Unless it's to spite me. Please roll out a container platform to spite me. Oh, I need some entertainment. At the end of the day, a really good litmus test for whether or not containers are right for you is to ask yourself, do you want containers or a blog post? If you are listing all the reasons that you need a container platform, and reason number 2 is, it would be rad. Don't do it. It's not worth it. There are way better legacy solutions out there with greater rates of adoption and greater communities for support than containers. You really don't need to do it because, spoiler alert, it's okay not to use containers. It really is. They're just one tool in the toolbox, and if they're not actually solving the problem you have, don't do it because that container platform is going to be around a lot longer than your Hacker News ranking. But if you do decide to roll out containers, just know that they can be a little tricky, but if you have a good team by your side, you will get it in no time. Thank you very much.
Alice, that was amazing. Thank you. So, go enjoy lunch. Come back after lunch, 1:15. On this stage, we'll be doing open space proposals. And spoiler alert, you may get a chance to hear a little bit more from Alice and Liz and some of the rest of us in open space.